Our project here is to really leverage the Da Vinci robot to create an image guidance system for partial nephrectomy and also other surgeries. And the current challenge with these types of surgeries is this problem that actually Dr. Clayman brought up earlier this morning, where you as a surgeon, while you're operating, in order to use preoperative images, you have to think about these CT 2D images and all of these slices that you've seen and try to put them together into this 3D model in your mind and then match them to the anatomy you're seeing through the endoscopic camera, right? So trying to move beyond this mental co-registration, our system aims to create an image guidance system that provides real-time visualization of both the anatomy and the robotic instruments, and also allows surgeons to see the subsurface features and other critical features in their actual surgical scene. So the first thing that we need to accomplish in order to implement this image guidance system is accurate tracking of the Da Vinci manipulators, because we're going to use those for both the visualization and the registration, as you'll see in a moment. So others have used endoscopes for tracking the manipulators, but for this project, we're actually using a kinematic modeling approach. So through a collaboration with Intuitive, we're actually able to use the Da Vinci API to track the joint positions of the robot in real time, and then we use a calibrated kinematic model to achieve sub-millimeter positioning accuracy, so we can predict the location of the Da Vinci manipulators with sub-millimeter precision. I don't have time today to talk about our calibration method, but if you would like to hear more about it, I would encourage you to come speak to me at the poster session later. So now that we can track our instruments, we are using them to perform a touch-based registration, which works as I'm about to describe. So we have the surgeon lightly trace on the surface of the kidney a curve, which we are also simultaneously tracking in the robot's workspace using the calibrated kinematic model that I mentioned. And then by doing this, we have used the manipulator to digitize the surface of the kidney, and then we can automatically calculate an optimal registration between the curve that the surgeon has traced and the 3D image of the kidney. And so this is an entirely automated process. There isn't any eyeballing involved with this. And as you can see, this process can be used to reveal features that aren't visible with the naked eye. So the main subject of our paper was a model-based assessment of this technology, and you can see our experimental setup here. So we have we've placed our phantom model on a reference platform and partially obscured the model in fat, and underneath that fat, as you'll see in a moment, is actually an exophytic tumor that the surgeons obviously can't see currently. And then we also outfitted the reference platform and the robot with optical tracking markers, which we use to validate our registration. So this is a video of the actual experiment. So you can see here, this is Dr. Cavusi gently tracing along the surface of our phantom, continuing to trace here. And now, after the registration, as you can see, the software can visualize the manipulators and their location relative to the target anatomy, and now the surgeon can see that tumor that's under the surface through the fat. So the next thing that we did to qualitatively assess the usefulness of this for localizing these subsurface features, we had the surgeons place these needles into the tumor through the fat, so you can see that here. And then finally, these are the results of our trials. So on the left here, you can see an image of the kidney's location as we measured it, and then on top of that, we've overlaid the registration, the kidney location as we did during the registration. And so our target error for this, our total registration error was around 1.9 millimeters. And then on the left, you can see a photograph So qualitatively, we did hit the center of that tumor through the fat. So from this trial, we can conclude first that this surface-based registration can be sufficiently accurate for image guidance, but also we've leveraged the Da Vinci in order to achieve this image guidance without you needing any other hardware in the operating room. So with that, I'll give it to the next speaker. Thank you very much.